Hello everyone, and welcome to William and I's bearing fault classification script. This is our project for our MM466 unit on machine learning algorithms. So our goal is to classify the health of bearings based off vibration data. So you can start off by opening up the final workspace.mat file. You'll see that there are multiple variables already loaded. Double click it to insert it into your workspace. Once everything is there, you can view it in the workspace. These are already processed so that you don't have to run the entire code again. First up, you'll see the feature extraction loop. This is how the entire 120 million data points were processed. We skipped the combined data points because you would have to individually separate the three main faults. So once all the data sets were created, we gave it the title features, which is present in the workspace as a whole variable of 1200 rows by 19 tables. And then you can start off with exploratory data analysis. That is a runnable code. Shouldn't take too long, where you get the histograms of all features. Then you can follow up with a correlation heat map just to see how each feature is correlated against each other. Once you're satisfied with an analysis on that, we went along our dimensionality reduction technique of PCA, principal component analysis, and so you can run that as well. Principal component analysis just allows us to see how much of the data can be explained through different principal components, and if we can reduce we can reduce the training computational power. Once that's done, you can view the PCA using a Pareto chart, and you can see that there are four principal components, and the fourth principal component takes it right up to just over 95%. The first component is about 56%, and you only need 4 to explain most of the data. Using the principal components, we can then plot certain graphs such as G-scatter as well as 3D scatter. So the first G-scatter, we have PC1 versus PC2. You can clearly see certain classes such as the inner race, which is completely distinct from the other 4 classes, and you have a bit of clustering between between the outer, ball crack and healthy. And the same thing follows for PC1 against PC3, where you have 52.9% against 9.3%. There is a bit of clustering between 3 classes, however, the groups are still in the majority, so it should be easy for the machine model to classify. The same observations are present for PC1 against PC4, and the thing that is consistent amongst all of them is that the inner race is distinct. Almost all of its data points are far apart from the other classes, so inner race should have the least misclassifications. Ball crack and healthy should not be misclassified against each other. Outer race, since it falls in between the two, that's where the misclassifications could occur. The last part after our PCA is the 3D scatter plot. This just it's a 3D graphical explanation of the principal components and how each class organizes its data. Some will be highly organized, some will interfere with one another, as you can see in the second one of principal component 2 against principal component 3. There's a large spread for the inner race, whereas ball crack, healthy, and outer are highly clustered. And then we started off by training. This is the pure code, not using a classification learner app. And the reason being is that we felt that we had our highest accuracy, so we wanted to try the hard code itself, which we got an accuracy of 90.83. And then we moved on to using the classification learner app, where our highest trained model, which was the first model, was 94%. However, when we exported the model and trained it and tested it, it had a lower test accuracy. So here you can see that all the models are presented as structs, and there's certain instructions that you can use to call your model and you can test it. So we've tested a few of the models for its training accuracy against its test accuracy once it's exported to the workspace. And we tested against the Y-test, which was a 240 by 1 categorical. And everything is viewable if you want to open up the classification learner app. You just have to load the classification learner session MM466 project, and you can see how all the models were trained, their training accuracy as well as their validation accuracy. And the entire table is exported into Excel, which cannot be seen here, and it is all present in the report, which has a detailed analysis as well. Thank you.